Okay, logicians, in section 8H, we learn about indirect proofs. Now, an indirect proof is sometimes known by its Latin title, reductio ad absurdum, which means reducing something to the absurd. And this is a method that starts and says, let's assume for the sake of argument that something is true. If that were true, it would lead to a contradiction. It would lead to crazy world. So the initial assumption can't possibly be true. The opposite must be true. In other words, it's a method that starts by assuming, for the sake of argument, the negation of the conclusion you're trying to reach, and then validly deriving a contradiction from that assumption. So in our example here, we've got these premises, and we're trying to prove that either L or M is true. So we assume, for the sake of argument, that L or M is not true. Right? So we assume the opposite. That line is going to be justified by assumption IP, assumption indirect proof. And this is an indented proof sequence like conditional proof. So like with the conditional proof, you can draw on premises that are before and outside the sequence, but you can't use stuff from inside the sequence once you get outside of it. Okay, so if you assume that it's not the case, the L and M, then you apply these different rules. By De Morgan's, you get not L and not M. Then by modus ponens, you can get N. By simplification, not M. By modus ponens, not N. And then here's what we've gotten. You've proven both that N is true and that its opposite, not N, is true. So the last line of the proof sequence of an indirect proof is going to be a contradiction, always. It's going to be a conjunction. It's going to say that N and not N is true, or it won't necessarily be N. It'll be any statement, but you're going to have a statement and its negation are both true, which is, of course, impossible. It's an absurdity. So once you get to that point, you end the proof sequence and you discharge it. And the discharge of an indirect proof sequence will be the negation of the assumption. So we assumed not L or M. The discharge is going to be not L or M. And then by double negation, we get our conclusion that we wanted, which is L or M by double negation. So that's how it works. Here's a couple things to keep in mind. First of all, remember, basic idea, the first line of that indented sequence should be the statement whose negation you are trying to prove. So if you're trying to prove that not X is true, you want to assume that X is true, and then you'll show how that leads to a contradiction. You'll discharge it with not X. But what if you're trying to prove that X is true? In that case, you're going to assume that not X is true. That'll lead to a contradiction, and the discharge will be not X. And then you can apply double negation, and you will get X, which is what you were going for all along. Remember that the last line of the indented sequence before the discharge has to be a conjunction. It's going to be a conjunction of any statement and its negation. So for example, A and not A. Those are the basics. Now, let's look at some examples. Okay. So in example 1 here, we've got premise 1, if P or not P, then not Q. Premise 2, if R, then Q, and we're trying to prove not R. So you might look at this and think, you might try some different ways of getting it, and you're like, I can't figure out how I'm going to get this. Maybe there is another way to do it. I don't know, but I know one way we can do it is with indirect proof. And I want you to notice one thing that hopefully stuck out to you a little bit, and that is this antecedent here is a necessary truth. It's necessarily true that either P or not P is true. one or the other has got to be true, right? But they can't both be true at the same time. That's going to become key in just a second. So in any case, let's say we're going to try to get this final conclusion, not R, by indirect proof. So I'm going to say my proof sequence is going to start with 3. I don't know where it will end. It'll be indirect proof. Now, I'm going to do it. Here's my indented sequence, and my assumption is going to be the opposite of what I am going to get eventually of not R. So I'm going to assume not R. Sorry, I'm going to assume R. I was making that too complicated. My bad. I'm going to assume R. Now, I want to produce a contradiction. How am I going to do that? What kind of contradiction am I going to get? Well, like I said, if this is a necessary truth, then its negation is going to be a necessary falsehood. So I think that's going to be involved. And as you can see, so if R is true, then I can get Q by modus ponens. Now, if Q is true, then I can use that to do a modus tollens on this. And I'll have to do double negation first. And that will give me the negation of this necessary truth, which will give me a contradiction. So you can see how this will work. So I'm going to do not Q for double negation. Then that gives me by modus tollens. Sorry. I've got not P or not P. And then by De Morgan's, you get not P or not P. And that's my contradiction right there. I don't even need to do like anything else. I mean, I could do double negation on this, but it doesn't matter. I've got not P, and then I've got the negation. I've got not P. So there I go. I'm going to discharge it. This is going to become line 8. And I've got 3 through 7 by indirect proof. So that's how that works. Let's try another example. Here I've got one premise. It's a conjunction. If not Q, then not S, and if not S, then S. And I'm trying to get conclusion Q. Now, you can probably see that I could simplify this into 2 distinct lines. We can go ahead and do it just to see what if that suggests any other way of solving this. I can get that by simplification. And I can get this by simplification as well. I hope you noticed something weird about this line on line 3, and that is if S is false, then S is true. That's a contradiction. That's going to be the key to producing the contradiction in the indirect proof I'm about to pull off here. So hopefully you've noticed that. Anyway, but given what I've got, it's not clear to me how am I going to get Q out of there. I don't know. So I'm going to do it by indirect proof. I'm going to assume the opposite, and then I'm going to get this, but sorry, that's actually not what I'm going to do. I'm going to assume the opposite. I'm going to assume that Q is false. I'm going to assume not Q. And then somehow I'm going to prove that that leads to a contradiction. Now, when I discharge it, it's going to give me not Q, right? Because I started with not Q, then so then it'll be the negation will be the discharge. And that'll be from 4 through something by indirect proof. And then I'll get Q itself by double negation of not Q. All right, so back to our indirect proof here, the proof sequence. Here's what I've got, and I'm trying to generate a contradiction. And I'm pretty sure the contradiction is going to be S and not S. I think that's the way it's going to turn out. And you can probably see just by looking at it how we can do this. First of all, I can get not S by modus ponens from lines 2, 4. Then I can get S by another modus ponens from lines 3 and 5. But that is that's gonna, now I can put them together in a contradiction, right? Because I've got not S and S from lines 5 and 6 by conjunction. And that's absurd. So now I've got line 8, I'm going to discharge it. And then by double negation on line 8, I get Q. Hopefully that makes sense. Remember, as with conditional proof, you can do indirect proofs inside of indirect proofs, or indirect proofs inside conditional proofs, or vice versa. So you can nest these indented proof sequences of both types. All right, have fun with that.